Did you know that the same mathematical proportion governing the spiral of a seashell also determines the shape of our galaxy? That the branching patterns in your lungs follow exactly the same fractal patterns we find in tree branches or lightning bolts cutting across the sky? Welcome to Dream Scientist, where we explore the most fascinating mysteries of the universe through a contemplative and poetic perspective. I'm your guide on this nighttime journey of discovery, where science and contemplation meet to reveal the deepest truths of existence. Where are you right now? How do you feel? This is a special moment, the beginning of a gentle and profound exploration of one of nature's most beautiful secrets, its hidden geometry. Allow me to invite you to close your eyes for a moment. Take a deep breath. Feel the air entering your lungs, expanding your chest, then let it out slowly. Now, when you open your eyes again, I want you to observe the world around you with a different gaze. Not an ordinary look, but a curious one, as if you were an explorer who had just arrived in an unknown territory. Have you ever noticed how a simple leaf can contain within itself an entire universe of patterns? How the veins running across its surface branch out following a mysterious, almost mathematical order? Or how the spiral of a seashell seems to echo the same shape we find in distant galaxies, majestically spinning in the cosmos. There is something that connects the invisible architecture of a sunflower with the grandiose structure of a spiral galaxy. Something that unites the delicate design of ice crystals on your window with the fractal patterns of lightning bolts cutting through the sky during a storm. Something that makes our bodies, apparently unique and individual, follow proportions that can be found in the most ancient Greek temples and the most sublime Renaissance paintings. This something is nature's secret geometry, a silent, elegant, and precise language that permeates everything that exists. It's as if the universe were a great architect who, billions of years ago, decided to use the same mathematical tools to build both a small fern and an immense mountain range. Both the water swirling down the drain and the hurricane seen from space. Have you ever wondered why certain shapes bring us an inexplicable sense of beauty and harmony? Why a person's face can seem more attractive when its proportions follow certain mathematical rules? Why music can move us when its frequencies relate according to specific geometric proportions? The answer may lie in the fact that we ourselves are made of this same secret geometry. Our cells divide following fractal patterns, our bones grow in golden proportions, our hearts beat in rhythms that echo the very pulsations of the cosmos. We are literally made of the same geometric substance that shapes the stars and oceans. Today, I invite you to embark with me on a contemplative journey through this fascinating territory. We'll walk together through the spirals that connect the infinitely small to the infinitely large, through the fractals that reveal infinite complexity hidden in apparent simplicity, through the symmetries that show how balance is a fundamental force of the universe. This is not a journey that requires haste. On the contrary, it's a gentle walk, almost meditative, where each step reveals new horizons of understanding. It's an exploration that invites you to pause, to breathe, to contemplate. Because nature's secret geometry cannot be understood only with the mind. It needs to be felt, experienced, lived. Are you ready to discover that the world around you is not a random collection of shapes and colors, but rather a geometric symphony carefully orchestrated? That each petal, each crystal, each movement of ocean waves carries within it a message encoded in a universal mathematical language? Then take a deep breath once more and let yourself be carried away. Our journey is just beginning. Close your eyes and imagine a seashell. Visualize its smooth curves, the way it coils upon itself, creating a perfect spiral that seems to dance between your hands. This shell, which you might have found on a distant beach during a summer afternoon, carries with it one of the universe's deepest secrets. The shell's spiral is not just a beautiful form, it's the physical manifestation of a mathematical law that governs growth and expansion throughout all of nature. It's the same spiral we find at the center of a galaxy, in the arms of the Milky Way that extend for millions of light years, slowly rotating in a cosmic dance that began billions of years ago. Have you ever closely observed the center of a sunflower? Those small flowers that form its heart are not randomly arranged. They follow two series of interlacing spirals, one rotating clockwise, the other counterclockwise. And the number of these spirals? It always follows a specific mathematical sequence, 21 and 34, or 34 and 55, or 55 and 89, numbers that are part of a series discovered by an Italian mathematician named Fibonacci more than 800 years ago. But this discovery wasn't really a human invention. Fibonacci merely unveiled something that had existed since the beginning of time. Nature had been using this sequence long before any mathematician was born, long before any civilization arose on Earth. It's as if the universe had chosen this specific proportion as its preferred language for creating and expanding. Think of the snail's spiral slowly gliding through your garden after the rain. Each new turn of the spiral is approximately 1.618 times larger than the previous one. This number, known as the golden ratio or divine proportion, appears in places so diverse it seems almost magical. It's in the growth of ram horns, in the arrangement of fish scales, in the architecture of honeycombs, in the shape of bird eggs. Have you noticed how your own body carries these proportions? The distance from your elbow to your fingertips, divided by the distance from your wrist to your fingertips, results in the golden ratio. Your phalanges, the small bones of your fingers, are in golden proportion to each other. Even your heartbeat follows rhythms that echo these mathematical proportions. Spirals invite us to a deep reflection on the nature of time and growth. Unlike a circle, which is closed and repetitive, the spiral is a form of movement that grows and expands but maintains its essential identity. It's as if it were a perfect metaphor for life itself, always advancing, always growing, but never losing its essence. When a hurricane forms over the ocean, it doesn't consciously choose the spiral form. This shape emerges naturally from the forces that govern it: Earth's rotation, atmospheric pressure differences, air mass movement. It's as if the planet itself were an artist painting with winds and clouds, creating these meteorological masterpieces that can be seen from space. Similarly, when a galaxy forms, its spiral arms are not the result of intentional design. They emerge from gravitational forces, rotation, matter density. It's physics itself that sculpts these sublime forms in the fabric of space-time. And if we ask ourselves why nature consistently chooses these spiral forms, the answer may lie in efficiency. The spiral is one of the most efficient forms of growth, allowing an organism or system to expand while occupying maximum space with minimum energy. It's an elegant solution to the universal problem of sustainable growth. Have you observed how your fingerprints form unique spirals? Every human being who has ever lived or will have a different pattern, but all follow the same basic geometric principles. It's as if each of us carries at our fingertips a unique geometric signature of the universe. Spirals also speak to us about the cyclical yet evolutionary nature of time. Unlike the linear conception of time, where events succeed each other in a straight line, the spiral suggests that time can be cyclical but always ascending. We return to similar points but always at a higher level of understanding or experience. When you look at a spiral, whether in a shell, a galaxy, or a water whirlpool, you're contemplating one of the universe's most fundamental forms. You're seeing the very mathematics of creation manifesting before your eyes. It's as if nature were whispering, "See, there is order behind apparent chaos. There is beauty behind complexity. There is simplicity behind diversity." And perhaps the deepest question that spirals pose to us is if there exists such perfect mathematical order governing everything from the smallest shells to the largest galaxies. What does this tell us about our own nature and our place in the cosmos? Imagine you're walking through a forest in autumn. Golden leaves create a soft carpet under your feet, and you stop before an ancient tree, its roots deeply intertwined with the earth. Observe this tree's branches. See how they ramify, dividing into smaller branches, which in turn divide into even smaller branches, and so on until they reach the most delicate leaves. Now imagine you have a powerful magnifying glass and decide to examine one of these leaves more closely. You would discover that the leaf's veins follow exactly the same branching pattern as the tree's branches. And if you had an even more powerful microscope, you would see that the leaf's cellular structure repeats this same pattern again. This is the essence of fractals, patterns that repeat at different scales, from the infinitely small to the infinitely large. It's as if nature had a basic template and used it repeatedly, creating infinite complexity from simple rules. Have you noticed how the shape of a Romanesco broccoli seems to contain infinite smaller versions of itself? Each small protuberance is a miniature version of the total structure. It's as if you were looking at a recursive universe where each part contains the whole, and the whole is formed by its parts. This self-similar quality of fractals is not just a mathematical curiosity. It represents an elegant solution to a fundamental problem of nature: how to create infinitely complex structures with finite resources. A tree, for example, needs to maximize its surface contact with air and sunlight. The fractal structure allows it to do this using the least possible amount of energy and material. Think of your lungs. They are essentially a fractal structure. The bronchi branch into bronchioles, which branch into alveoli, creating an internal surface that, if flattened, would occupy approximately 70 square meters, the size of a small house, all compacted within your chest. This fractal geometry allows you to breathe efficiently, exchanging oxygen for carbon dioxide in a constant molecular dance. Your circulatory system follows the same principle. Your arteries branch into smaller arteries, which branch into microscopic capillaries, creating a fractal network that reaches every cell in your body. If all your blood vessels were connected in a straight line, they would extend approximately 100,000 kilometers, enough to circle the Earth 2.5 times. Have you contemplated the shape of lightning during a storm? Those branching patterns that cut across the sky like luminous veins are not random. They follow the same fractal geometry we find in river deltas, ice cracks, neural networks in your brain. It's as if electricity, water, and thought spoke the same geometric language. The mountains you see on the horizon are also fractals. If you observe a mountain range from afar, you'll see an irregular silhouette against the sky. Approach, and you'll see that each individual mountain has its own irregularity. Continue approaching, and you'll see that each rock has its own complex texture. This property, where the level of complexity remains constant regardless of the observation scale, is one of the most fascinating characteristics of fractals. Benoit Mandelbrot, the mathematician who popularized the concept of fractals in the 20th century, asked an apparently simple question: what is the length of England's coastline? The answer, he discovered, is that there is no single answer. The more precisely you measure, taking into account each small cove, each boulder, each grain of sand, the longer the perimeter becomes. England's coastline, like all coastlines, is a fractal. This discovery revolutionized our understanding of nature. For centuries, we tried to describe the natural world using Euclidean geometry, points, lines, circles, squares. But Mandelbrot showed us that nature prefers a more complex, more organic, more living geometry. Have you observed how clouds form in the sky? They are not simple geometric shapes, but complex fractal structures. Each cloud contains smaller structures within itself, which in turn contain even smaller structures. It's this fractal quality that makes clouds so fascinating to observe. There are always more details to discover, always more complexity to contemplate. Fractals also offer us a new perspective on beauty. Perhaps our aesthetic attraction to certain natural forms, the shape of a tree, the texture of a stone, the design of a river, derives from the fact that our own brain is a fractal structure. We recognize in external fractals the same geometry that constitutes our thought processes. When you dream, the images that emerge in your mind follow fractal patterns. Memories connect with memories, creating associations that branch into even more complex associations. It's as if consciousness itself were a fractal structure, where each thought contains other thoughts in infinite recursion. And if we consider that we are made of fractals, that we think in fractals, that we live in a fractal world, this leads us to a profound question. Might reality itself be a fractal structure? Might the universe be a great fractal where each part contains information about the whole? Stop for a moment and look at your hands. Observe how they are mirrors of each other. Not exact copies, but perfect reflections. Your right hand and your left hand share the same basic shape, but are inverted, as if one were the reflection of the other on a perfectly calm water surface. This is one of the most intimate manifestations of symmetry that you carry with you at every moment. Your face, though unique and individual, is approximately symmetrical. Your eyes, your ears, your arms, your legs, all arranged in a bilateral symmetry that characterizes most complex living beings. But have you ever wondered why nature chooses symmetry so frequently? Why doesn't a bird have a wing in the middle of its back? Or why doesn't a butterfly have 3 wings of different sizes? The answer lies in efficiency and function. Bilateral symmetry allows coordinated movement, dynamic balance, and efficient distribution of bodily resources. Imagine a fish swimming in a river. If it weren't symmetrical, every movement would be an effort to correct imbalance. Symmetry allows it to move through water with grace and efficiency, each fin working in harmony with its partner on the opposite side. It's as if nature had discovered that symmetry is the language of functional elegance. Now think of a flower. Many flowers exhibit radial symmetry. Their petals radiate from a common center like the spokes of a wheel. This symmetry is not just aesthetically pleasing. It serves a crucial evolutionary purpose. A symmetrical flower can be seen and accessed by pollinating insects coming from any direction. It's a perfect visual invitation, a biological landing strip that works in 360 degrees. Have you contemplated a snowflake? Each one is unique, but all follow perfect hexagonal symmetry. It's as if water itself, when it freezes, chooses this form as its most natural expression. This symmetry is not externally imposed. It emerges from water's molecular properties, from how molecules organize when temperature drops. Symmetry in snowflakes teaches us something profound about the nature of order. It's not something that needs to be forced or imposed. It emerges naturally when conditions are adequate. It's as if symmetry were a state of equilibrium preferred by the universe, a point of stability toward which natural systems tend. But symmetry in nature goes beyond visible forms. It also manifests in movement and time. Think of ocean waves. They are not identical, but follow symmetrical patterns. Each wave is followed by another, in a rhythmic sequence that seems to dance with Earth itself. This temporal symmetry creates the rhythms that govern everything from tides to the life cycles of marine organisms. Have you observed how birds fly in formation? When geese migrate, they organize in symmetrical patterns, the famous V that cuts across the sky. The symmetry is not just beautiful to see. It serves a crucial aerodynamic purpose. Each bird takes advantage of the air current created by the bird in front of it, saving energy on a journey that can cover thousands of kilometers. Symmetry also manifests in the architecture of honeycombs. Bees build their combs in perfect hexagons, a shape that maximizes storage space while minimizing wax use. This choice is not conscious, it's the result of millions of years of evolution, where hives that use materials more efficiently had survival advantages. But perhaps the most fascinating symmetry is that found in spacetime itself. Einstein showed us that the universe has fundamental symmetries. The same laws of physics apply here and in distant galaxies today and billions of years ago. It's as if the entire cosmos were governed by a set of symmetrical principles that maintain its consistency throughout all the immensity of space and time. Have you noticed how certain music seems perfectly balanced? This happens when melodies follow temporal symmetries, patterns that repeat, invert, mirror themselves over time. It's as if music were an auditory symmetry, a geometry made of sound and rhythm. Symmetry also offers us clues about the nature of beauty. Studies show that more symmetrical faces are generally considered more attractive. This may be because symmetry signals genetic health, adequate development, absence of harmful mutations. Our attraction to symmetry may be an evolutionary adaptation that helps us identify genetically healthy partners. But perfect symmetry can be monotonous. Nature often introduces small asymmetries that make forms more interesting and dynamic. Your face, for example, is not perfectly symmetrical, and it's these small asymmetries that make your face unique and expressive. When you look at a Gothic cathedral, you're contemplating symmetry translated into stone and light. Medieval architects intuitively understood that symmetry creates a sense of divine order, of transcendent harmony. It's as if they were trying to build spaces that reflected the fundamental symmetry of the cosmos. Symmetry invites us to a deep reflection on balance and harmony. In an era where everything seems chaotic and unbalanced, symmetry reminds us that balance is possible. That harmony is a natural state toward which systems tend when undisturbed. And if we think about our own lives, we can ask ourselves, where do we find symmetry? Where do we find balance? And how can we cultivate more harmony in our days, inspired by nature's symmetrical wisdom? Breathe deeply and imagine you're in an ancient library, surrounded by books containing the secrets of mathematics and art. On a table before you, there's a golden ruler that glows softly in the candlelight. This ruler is not an ordinary ruler. It's marked with a very special proportion, a proportion that the ancient Greeks called the division in extreme and mean ratio, and which today we know as the golden ratio. This proportion, represented by the Greek letter phi, is approximately 1.618, but behind this apparently simple number lies one of the universe's most fascinating constants. It's a number that spontaneously appears in places so diverse it seems almost impossible to be coincidence. Have you ever counted the petals of a daisy? You'll most likely find 13, 21, 34, 55, or 89 petals. These numbers are part of the famous Fibonacci sequence, where each number is the sum of the two preceding ones: 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. And here's the secret. When you divide any number in this sequence by the previous one, the result increasingly approaches the golden ratio. It's as if nature had chosen this proportion as its preferred signature. It appears in plant growth, in animal body architecture, in galaxy structure. It's a mathematical constant that seems to connect the realm of pure ideas with the tangible physical world. Think of a nautilus shell. As it grows, each new chamber is approximately 1.618 times larger than the previous one. This proportion allows the shell to grow while maintaining its essential shape, in a spiral that is both functional and beautiful. It's as if the shell were a physical demonstration of the golden ratio crystallized in calcium carbonate. Have you measured the proportions of your own body? The distance from the top of your head to your navel, divided by the distance from navel to ground, results approximately in the golden ratio. The distance from your shoulder to your fingertips, divided by the distance from elbow to fingertips, also approaches this proportion. Leonardo da Vinci knew this when he created his famous Vitruvian Man. He wasn't just drawing a human body, he was revealing that we are, literally, built according to golden proportions. It's as if we were walking mathematical works of art, living sculptures of divine geometry. But the golden ratio is not limited to static proportions. It also governs growth and time patterns. Think of a tree. The ratio between main trunk growth and secondary branch growth frequently follows the golden proportion. It's as if the tree were a growth symphony orchestrated by this mathematical constant. Have you observed how seeds organize in the center of a sunflower? They form two series of interlacing spirals, one clockwise, the other counterclockwise. And how many spirals are there in each direction? Always consecutive Fibonacci numbers, 21 and 34, or 34 and 55, or 55 and 89. It's as if the sunflower were a vegetable manifestation of pure mathematics. This organization is not coincidence. It represents the most efficient solution to the problem of how to pack the maximum number of seeds in the smallest possible space. Nature, through millions of years of evolution, discovered that the golden ratio offers the most elegant answer to this geometric challenge. The ancient Greeks discovered that rectangles with golden proportions were especially pleasing to the eye. They used this discovery in the architecture of the Parthenon, where the main facade fits perfectly into a golden rectangle. It's as if they had intuited that this proportion resonates with something deep in human nature. But why does the golden ratio seem so beautiful to us? One theory suggests that since we ourselves are built according to these proportions, we recognize in them a familiar harmony. It's as if we were seeing reflected in the external world the geometry that constitutes us internally. The golden ratio also appears in music. Many classical compositions are structured so that the climax occurs approximately at the golden point of the piece. It's as if composers, consciously or not, we're using this proportion to create tension and resolution more naturally and emotively. Have you noticed how certain paintings seem perfectly balanced? Often, this happens because the main elements are positioned according to golden proportions. Renaissance masters used this proportion not only in the general dimensions of canvases, but also in positioning elements within the composition. In nature, the golden ratio appears on scales ranging from microscopic to cosmic. It governs DNA molecule structure, crystal organization, galaxy shape. It's as if it were a fundamental law operating at all levels of reality. But perhaps the most fascinating aspect of the golden ratio is its ability to connect apparently unrelated domains. It unites mathematics and art, science and spirituality, form and function. It's as if it were a universal language that transcends barriers between different forms of knowledge. When you contemplate a flower, a human face, a work of art, a seashell, you're contemplating manifestations of the same fundamental proportion. It's as if the universe used the golden ratio as a musical theme that resonates through all its creations. And this leads us to a profound question. If this proportion appears so consistently throughout all of nature, from the smallest structures to the largest, what does this tell us about the fundamental nature of reality? Might there exist, behind the apparent diversity of the world, a deeper mathematical unity that connects all things? Imagine you're in a deep cave, where silence is so complete you can hear the beating of your own heart. On the surrounding walls, quartz crystals emerge from rock like towers of natural glass, each perfectly formed, each a demonstration of Earth's infinite patience. These crystals didn't form in a day, a decade, or even a century. They are the result of millions of years of slow and meticulous growth. Have you ever wondered how nature manages to create such geometrically perfect forms? A salt crystal, for example, is always a perfect cube, no matter where in the world it forms. A quartz crystal always has 6 faces, always the same angles, always the same proportion. It's as if matter had a geometric memory, an internal blueprint that guides its crystallization. This memory is not written in genes, like in living beings. It's encoded in matter's very atomic structure. When carbon atoms organize in a specific way, they create diamonds, the hardest known substance. When they organize differently, they create graphite, so soft we use it for writing. The difference isn't in the atoms, but in the geometry of their organization. Think of the snowflakes that dance in the air during a winter storm. Each one is unique, but all follow perfect hexagonal symmetry. This symmetry is not externally imposed. It emerges from water molecule properties, from how they bond when temperature drops. It's as if water itself had a geometric personality that expresses itself when conditions are adequate. Crystals teach us that order can emerge spontaneously from chaos. In a supersaturated solution, millions of atoms float apparently directionless. But when conditions are adequate, they begin to organize, atom by atom, following precise geometric laws. It's like watching the birth of order from disorder, a process that seems almost magical. Have you observed ice crystals forming on a cold window? They grow in fractal patterns, branching like microscopic trees. Each ramification follows the same geometric rules, creating a forest of crystals that is simultaneously delicate and mathematically precise. It's as if cold were a sculptor working with molecules, creating ephemeral art on the glass surface. Crystals also show us how time can be a creative force. A geode, that common rock on the outside that hides a world of crystals inside, forms over millions of years. Waters rich in minerals slowly penetrate a rock cavity and crystal by crystal, century after century, build underground cathedrals of extraordinary beauty. In Earth's depths, under immense pressure and temperature, giant crystals grow with a slowness that challenges our human understanding of time. Mexico's Crystal Cave houses gypsum crystals the size of trees, some over 500,000 years old. They're like temporal pillars connecting Earth's deep past with the present. Have you held a quartz crystal in your hands? If so, you were touching something that began forming when dinosaurs walked the Earth. You were touching crystallized time, mineralized patience, order slowly emerging from chaos over geological eras. Crystals also teach us about perfection and imperfection. A perfect crystal is rare in nature. Most carry small inclusions, microscopic flaws, irregularities that tell the story of their formation. These imperfections don't diminish their beauty, on the contrary. They make each crystal unique, like geological fingerprints. Crystal geometry has profoundly influenced human art and architecture. Egypt's pyramids echo pyramid crystal shapes. Gothic cathedrals, with their pointed structures and angular faces, seem inspired by crystalline architecture. It's as if humans, unconsciously, tried to imitate the geometric precision they observed in nature. Even our modern technology depends on crystalline geometry. The processors that make computation possible are made of crystalline silicon, where each atom is positioned with angstrom precision. It's the geometric perfection of crystals that allows electronic devices to function with the precision necessary for our digital age. Have you meditated while contemplating a crystal? Many spiritual traditions consider crystals as energy or consciousness focusers. Regardless of beliefs, there's something profoundly calming about contemplating these geometrically perfect forms. Perhaps because they represent pure order, infinite patience, sustainable growth over time. Liquid crystals, a phase of matter between solid and liquid, make possible the screens you use every day. These molecules organize in crystalline patterns but maintain some fluidity, allowing them to respond to electric fields. It's a demonstration of how crystalline geometry can be dynamic and responsive. On the atomic scale, all matter has a crystalline or amorphous structure. The metals that form your household utensils are crystalline arrangements of atoms. The salt you add to food are small cubes of sodium chloride, each grain a perfect miniature architecture. Crystals connect us with Earth's deep time. When you contemplate a crystal, you're looking at something that witnessed geological eras, that grew slowly through millions of years of planetary transformations. It's like having a window into nature's infinite patience. And perhaps crystals teach us something fundamental about growth and development. They grow by adding layer after layer, always maintaining their structural integrity. There's no rush, no shortcuts, just steady and consistent growth that results, eventually, in geometric perfection. This makes us reflect. In our own lives, do we adequately value patience and slow growth? Or are we always seeking immediate results, forgetting that nature's most beautiful things take time to form? Close your eyes and listen. Not just with your ears, but with your entire being. You may not perceive it, but you're immersed in a constant symphony of vibrations. Your heart beats at a specific rhythm, your lungs expand and contract at a regular frequency, the cells in your body vibrate at molecular frequencies. You are literally an orchestra of organized vibrations. This is not a poetic metaphor, it's pure physics. Everything in the universe vibrates. The atoms that compose your body vibrate, the light waves that allow you to see vibrate, the sound waves that carry music to your ears vibrate. Reality itself, at its most fundamental level, seems to be made of vibrations organized in specific geometric patterns. Have you observed the patterns that form in sand when subjected to sound vibrations? This phenomenon, discovered by German physicist Ernst Chladni in the 18th century, reveals something extraordinary. Sound has geometry. When a metal plate covered with sand is vibrated at different frequencies, the sand spontaneously organizes into complex geometric patterns, circles, stars, mandalas, forms that seem to have come from a sacred geometry book. Each frequency creates a different pattern, as if each musical note had its own geometric signature. It's as if sound were an invisible architect, sculpting forms in the physical world through pure vibrations. These patterns, known as Chladni figures, show us that music and geometry are two faces of the same cosmic coin. Think of the waves that form when you throw a stone into a calm lake. They expand in perfect circles, transporting energy through water without transporting matter. It's a visual demonstration of how vibrations propagate through media, creating geometric patterns in motion. But these water waves are just a small sample of a much broader phenomenon. Gravitational waves propagate through the very fabric of space-time, created when massive objects like black holes dance around each other. These waves, predicted by Einstein and detected only recently, are like wrinkles in the universe's geometry, vibrations in reality's very structure. Have you wondered why certain combinations of musical notes sound harmonious while others sound dissonant? The answer lies in mathematical proportions between frequencies. When two notes have frequencies in simple proportion, 2 to 1, 3 to 2, 4 to 3, they create harmony. When proportions are more complex, they create dissonance. This is not a cultural convention, but a fundamental physical property. Our ears, and consequently our brains, evolved to recognize these mathematical proportions as pleasurable. It's as if we were tuned to the universe's mathematics, capable of perceiving beauty in numerical relationships between vibrations. Earth itself vibrates like a giant bell. Earthquakes make the entire planet resonate at specific frequencies, creating waves that circle the globe several times. These Earth pulsations are so regular that scientists use them to study the planet's internal structure. It's as if Earth were a cosmic musical instrument, playing a constant geological symphony. Did you know your body resonates with specific frequencies? Each organ has its natural vibration frequency. When you sing or hum at a frequency that resonates with your lungs, you can feel the vibration in your chest. This is the basis of many meditative practices that use mantras or chants. They literally make your body vibrate at specific frequencies. Plants also respond to vibrations. Studies show that certain sound frequencies can accelerate plant growth, while others can inhibit it. It's as if plants had their own musical preferences, responding to frequencies that promote their well-being. Light, this electromagnetic vibration that makes vision possible, also has its geometry. When white light passes through a prism, it separates into colors that organize in a specific sequence, the spectrum. Each color corresponds to a specific vibration frequency, and these frequencies are related by harmonic mathematical proportions. Have you noticed how certain colors seem to vibrate when placed side by side? This happens when color frequencies create optical interference, making them appear to pulse or vibrate. It's as if colors were visual musical notes, creating optical harmonies and dissonances. On the atomic scale, electrons orbit nuclei at specific frequencies. When an electron jumps from one orbit to another, it emits or absorbs light at a precise frequency. It's as if each atom were a small quantum piano, capable of playing specific notes in the electromagnetic spectrum. This property allows scientists to identify chemical elements at astronomical distances. Light from a distant star carries the vibrational signatures of the elements composing it. It's as if the universe were a cosmic orchestra, where each star plays its own chemical melody. Even the vacuum of space is not truly empty, it seethes with quantum fluctuations, microscopic vibrations that appear and disappear in a constant energetic dance. It's as if nothingness itself vibrated, as if cosmic silence were actually a symphony of frequencies beyond our perception. Vibrations also connect different scales of reality. The frequencies governing planetary orbits are related by proportions similar to those we find in harmonic music. It's as if the solar system were a cosmic musical composition, where each planet contributes its own note to the gravitational symphony. Have you experienced the sensation of being in resonance with something or someone? This expression may be more literal than we think. When two people are truly connected, their brainwaves can enter synchronization, creating a measurable neurological resonance. It's as if human connection had a real vibrational dimension. And this leads us to a fascinating question. If everything in the universe is fundamentally vibration, if reality itself is a symphony of frequencies organized geometrically, what does this mean for our understanding of the nature of existence? Are we, perhaps, individual notes in an infinitely complex and beautiful cosmic composition? Extend your arms to the sides as if you wanted to embrace the entire world. Now imagine you're inside a perfect circle where your fingertips touch the circumference. If you also extended your legs, forming an X with your body, you would discover that your total height fits perfectly into a square inscribed in this same circle. You've just recreated one of the most famous images in art and science. History, Leonardo da Vinci's Vitruvian Man. But this is not just a beautiful illustration. It's a demonstration that your body carries within it mathematical proportions that echo the universe's fundamental geometry. You are literally a living manifestation of the same mathematics that governs galaxies. Flowers, crystals, and ocean waves. Look at your hands. Measure the distance from your middle fingertip to your wrist, then divide by the distance from the middle joint of your finger to your wrist. The result will be approximately 1.618, the golden ratio. Now do the same with your finger phalanges, the proportion between the proximal and middle phalanx, and between the middle and distal also approaches this divine proportion. You carry the golden ratio in your hands. Every time you gesture, every time you touch something, you're moving structures built according to the same proportion we find in nautilus shells, galaxy spirals, sunflower seed organization. It's as if your hands were precision mathematical instruments, sculpted by nature according to the same principles that govern all creation. Your face is also a map of golden proportions. The distance from the hairline to the eyebrow, from the eyebrow to the base of the nose, and from the base of the nose to the chin, ideally relate according to the golden ratio. The width of the mouth in relation to the width of the nose, the distance between the eyes in relation to the width of each eye, all these proportions tend toward the number 5. This is not an aesthetic coincidence. Faces that follow these proportions more closely are often perceived as more attractive. Not by cultural convention, but because we unconsciously recognize the mathematical harmony they represent. It's as if our perception of beauty were calibrated to recognize the sacred geometry that constitutes us. But human body proportions go beyond the golden ratio. Your entire body can be divided into segments that relate harmoniously. Total height divided by the height from navel to ground results in phi. Your arm span is approximately equal to your height. The distance from elbow to fingertips is approximately 1/4 of your height. These proportions are not arbitrary. They result from millions of years of evolution, where bodies with efficient proportions had survival advantages. An arm too long would be clumsy, too short would be inefficient. Nature found through natural selection the optimal proportions for movement, balance, and function. Have you noticed how babies have different proportions than adults? Their heads are proportionally larger, their arms and legs shorter. As we grow, our proportions gradually approach classical golden proportions. It's as if human growth were a process of convergence toward ideal geometry. Your circulatory system is a masterpiece of fractal geometry. If all your blood vessels were placed in a straight line, they would extend about 100,000 kilometers. This immense network is compacted in your body through a fractal structure that maximizes the efficiency of nutrient and oxygen distribution. Your lungs follow the same principle. The bronchial tree branches in fractal patterns, creating an internal surface of approximately 70 square meters, the size of half a tennis court, all folded within your chest. It's a demonstration of fractal geometry's efficiency in biology. Your brain is also a fractal structure. Neurons branch like microscopic trees, creating a network of connections that surpasses in complexity any system created by humans. With approximately 86 billion neurons and trillions of connections, your brain is perhaps the most complex structure known in the universe. But human body geometry is not limited to physical structure. Your biological rhythms also follow mathematical patterns. Your heart beats according to proportions that can be related to the golden ratio. Your sleep cycles follow patterns that echo planetary rhythms. Your hormones fluctuate in cycles that reflect natural periodicities. Have you observed how your body responds to specific musical rhythms? This happens because your internal biological processes already operate at related frequencies. When external music synchronizes with your internal rhythms, you feel a sensation of harmony and well-being. It's as if your body were an instrument that can enter into resonance with the surrounding world. Your body's bilateral symmetry, the fact that you have 2 eyes, 2 arms, 2 legs, is an elegant evolutionary solution to the problem of movement and balance. This symmetry allows coordination, energy efficiency, and redundancy of critical systems. It's as if nature had discovered that symmetry is the basis of elegant functionality. Even small asymmetries in your body have meaning. Your heart is slightly displaced to the left, allowing the lungs to have different spaces to accommodate their specific functions. These imperfections are not flaws, but evolutionary refinements that optimize function. Your movements also follow geometric patterns. When you walk, your arms swing at a frequency harmonically related to your leg step. When you run, your entire body enters a rhythmic synchronization that maximizes energy efficiency. It's as if human movement were a geometrically choreographed dance. The way you perceive the space around you is also influenced by your body's proportions. The concept of arm's length as a unit of measurement existed in many cultures because it represented a universal body proportion. Your body is literally your first ruler, your first instrument for measuring the world. And perhaps most fascinating is that these proportions are not just physical, they can also influence psychological and spiritual aspects. Practices like yoga and Tai Chi consciously work with these proportions, using body geometry as a path to altered states of consciousness and well-being. This leads us to a profound reflection. If we are built according to the same mathematical proportions that govern the cosmos, if we carry in our bodies the sacred geometry of the universe, what does this tell us about our relationship with the totality of existence? Are we microcosms that reflect the structure of the macrocosm? Imagine you're standing before the Mona Lisa in the Louvre. Thousands of people have passed by before you, all captured by something inexplicable in that enigmatic smile, in that gaze that seems to follow you. But you might not know that part of this painting's magic lies not only in Leonardo da Vinci's talent, but in the secret mathematics he used to compose the work. If you traced invisible lines over the painting, you would discover that Mona Lisa's face fits perfectly into a golden rectangle. Her eyes are positioned exactly at the points that divide the canvas according to the divine proportion. The entire composition follows a geometry that resonates with something deep in our aesthetic perception. This is not a coincidence. Leonardo da Vinci studied mathematics and geometry deeply, consciously applying golden proportions in his paintings. He understood something that artists have intuited for millennia. There exists a mathematics of beauty, a geometry that makes certain compositions universally appealing. Have you ever wondered why certain paintings seem balanced, even when they're not symmetrical? Why an asymmetrical composition can seem more dynamic and interesting than a perfectly centered one? The answer often lies in the unconscious or conscious application of specific mathematical proportions. The rule of thirds, used by photographers and painters, is a simplification of the golden ratio. When we divide an image into 9 equal parts with 2 horizontal and 2 vertical lines, the points where these lines intersect are naturally attractive to the eye. It's as if our visual perception were magnetically drawn to these specific proportions. Think of Egypt's pyramids. They are not just impressive monuments, they are mathematical statements in stone. The Great Pyramid of Giza incorporates the number pi, the golden ratio, and proportions that echo Earth's dimensions. It's as if ancient architects were trying to build a geometric replica of the cosmos. Have you walked inside a Gothic cathedral? Those vaults that rise to the sky, those arches that seem to defy gravity, are not just beautiful, they are mathematically precise. Medieval architects used proportions based on square roots and harmonic ratios to create spaces that literally elevate the spirit. Music and architecture have always been mathematical sisters. Harmonic musical intervals, octave, perfect fifth, perfect fourth, correspond to simple proportions: 2:1, 3:2, 4:3. These same proportions were used by architects to determine column dimensions, ceiling heights, facade proportions. When you hear music and feel it elevates your soul, you may be responding to these mathematical proportions translated into sound frequencies. Bach, perhaps the most mathematical of composers, structured his fugues and canons according to proportions that reflect nature's very structure. Have you noticed how certain sculptures seem to vibrate with life of their own? Michelangelo, when he sculpted David, didn't just copy human proportions, he idealized them according to mathematical principles. The statue incorporates golden proportions that make the figure more harmonious than any real human being. Islamic art developed an extraordinary tradition of geometric patterns. Look at Alhambra's tiles, mosque mosaics, Arab palace decorations. You'll see patterns that repeat infinitely, without beginning or end, creating a sense of transcendence through pure geometry. These patterns are not just decorative, they are mathematical meditations. Islamic artists understood that contemplation of perfect geometric patterns could be a path to elevated spiritual states. It's as if mathematics were a language capable of connecting the finite with the infinite. Have you contemplated a Tibetan mandala? These complex circular drawings are geometric maps of the cosmos, where each element is positioned according to sacred proportions. Creating a mandala is both an artistic exercise and a spiritual practice, where geometry becomes a path to transcendence. The Impressionists discovered something fascinating about visual perception. When complementary colors are placed side by side in small dots, the eye mixes them at a distance, creating optical vibrations that make paintings seem luminous. This technique explores the mathematics of visual perception, how our brain processes optical information. Have you wondered why certain color combinations seem harmonious? The answer lies in the mathematics of the light spectrum. Colors that are in specific proportions in the spectrum create visual harmonies, just as notes in specific proportions create musical harmonies. Modern art consciously explored these mathematical relationships. Mondrian reduced painting to straight lines and primary colors, organized according to golden proportions. Kandinsky explored synesthesia between geometric forms and musical sounds. It's as if modern artists wanted to reveal the mathematical structure underlying aesthetic experience. Brancusi's sculpture seeks essential forms, reducing complex objects to their fundamental geometries. His bird sculptures don't look like real birds but capture the geometric essence of flight, the mathematics of movement through space. Have you noticed how fractal art, created by computers, can be surprisingly beautiful? This happens because it reveals patterns that exist in nature, proportions that our brain recognizes as harmonious. It's as if mathematics itself had an intrinsic aesthetic dimension. Photography also unconsciously uses mathematical principles. When a photographer feels that a composition is right, they're often responding to golden proportions, symmetries, patterns that echo natural geometry. And perhaps most fascinating is that our aesthetic response to these mathematical proportions may be evolutionary. Organisms that could recognize harmonic patterns in nature, symmetry indicating health, proportions indicating reproductive maturity, had survival advantages. Our capacity to appreciate beauty may be literally a biological adaptation to the world's geometry. This leads us to a profound question. If the art that most moves us is that which incorporates nature's mathematics, does this mean that true art is a discovery, not an invention? Are great artists revealing universal geometric truths or creating beauty from nothing? Observe a raindrop slowly sliding down your window. See how it hesitates, accelerates, joins with other drops, creating unpredictable but elegant paths across the glass. That apparently random movement actually follows precise physical laws, surface tension, gravity, air resistance, that combine to create a miniature mathematical dance. Now expand your perspective. Imagine you're seeing from space the oceanic currents of planet Earth. They form giant spirals, whirlpools that can be hundreds of kilometers in diameter. These currents follow the same spiral geometry we find in a galaxy, a hurricane, a seashell. It's as if movement in the universe had a consistent geometric signature, from the microscopic to the cosmic. Have you observed how birds fly in flocks? That aerial dance that seems choreographed is not the result of conscious planning. Each bird follows 3 simple rules. Stay close to neighbors, avoid collisions, move in the group's average direction. From these simple rules emerges complex and beautiful collective behavior, a perfect example of how geometric patterns can emerge from simple local interactions. Fish schools do the same thing, creating fluid forms that undulate through water like single organisms. Each individual fish responds only to its immediate neighbors, but the result is coordinated movement that can involve thousands of individuals. It's as if geometry were a universal language of coordination. Think of tidal movement. Twice a day, entire oceans move in response to the gravitational attraction of the moon and sun. This movement follows predictable patterns that can be calculated with mathematical precision. Tides create waves that travel around the planet, invisible but powerful, connecting distant beaches in a global aquatic symphony. Have you walked on the beach during low tide and seen the patterns water leaves in the sand? Those undulations, those wavy textures, are natural fractals created by the interaction between water, sand, and gravity. Each small wave carries information about the larger waves that created it, in a hierarchy of patterns extending from centimeter ripples to oceanic tides. Wind also sculpts geometric patterns. Desert dunes are not random formations. They have specific geometries determined by wind speed, sand grain size, terrain topography. These dunes migrate slowly through the desert like giant waves frozen in slow-motion camera movement. When you breathe, You're participating in a movement pattern that connects you with the entire biosphere. The oxygen entering your lungs was produced by plants through photosynthesis. The carbon dioxide you exhale will be absorbed by other plants, continuing a cycle that connects all life on Earth in a global chemical dance. Your own body is a symphony of coordinated movements. Your heart beats following rhythms that can be described mathematically. The electrical waves governing each beat follow specific geometric patterns. When these patterns alter, doctors can diagnose heart problems just by observing the geometry of electrocardiogram tracings. Have you seen brainwaves recorded on an electroencephalogram? They also follow complex geometric patterns. When you sleep, your brain waves change frequency and amplitude according to predictable sequences. It's as if your consciousness danced through different states following precise neurological choreography. The movement of planets around the Sun follows perfect ellipses, geometric forms that were described mathematically centuries ago. But what's even more fascinating is that these planetary movements create harmonic proportions, the same proportions we find in music. It's as if the solar system were a cosmic orchestra playing a gravitational symphony. Did you know that Earth not only orbits the Sun, but also oscillates like a spinning top? This movement, called precession, creates cycles of approximately 26,000 years that influence Earth's climate. It's a movement so slow that entire civilizations are born and die before one complete oscillation finishes, but its effect is profound and lasting. Light also moves in geometric patterns. When you see a rainbow, you're observing white light being separated into its color components according to specific angles. Each color emerges from rain at a precise geometric direction, creating an arc that's always the same shape, no matter where in the world you are. Distant planets, when they pass in front of their stars, create light patterns that astronomers can detect. It's as if each planet had its own geometric signature in light, allowing us to discover worlds trillions of kilometers away just by observing stellar brightness patterns. Have you observed how smoke moves in air? It begins in smooth laminar flows but then becomes turbulent, creating vortices and whirlpools that follow chaos mathematics. This transition from order to apparent disorder is governed by mathematical equations that describe how small perturbations can grow and create complex patterns. The dance of leaves in the wind is not random. Each leaf has a specific shape that determines how it interacts with air. Wide, flat leaves create different turbulence than narrow, pointed leaves. The resulting movement follows aerodynamic principles that can be mathematically modeled. When you walk, your body automatically adjusts to maintain balance. Sensors in your inner ear detect changes in orientation and send signals to specific muscles. This control system is an example of real-time geometric feedback. Your body constantly calculates angles and adjusts positions to keep you upright. Earthquakes also follow geometric patterns. Seismic waves propagate through Earth in forms that depend on the planet's internal structure. P waves, primary, travel faster than S waves, secondary, creating arrival patterns that allow seismologists to triangulate a quake's exact location. Have you seen time-lapse of plants growing? The movement is hypnotic, shoots emerging from soil, leaves unfolding, vines seeking support. Each movement follows chemical gradients and light stimuli, creating a slow-motion plant dance that reveals the geometry of growth. Animal migration creates seasonal patterns on a planetary scale. Migratory birds follow specific routes, connecting distant regions in a movement network that has repeated for millions of years. These routes follow geometries determined by prevailing winds, Earth's magnetic fields, and food availability. Whales also migrate, creating invisible oceanic highways connecting polar waters to tropical seas. They navigate using magnetic fields, star positions, and seafloor topographic characteristics. It's as if the planet were crossed by a natural navigation network that animals know intuitively. Even apparently chaotic movements have underlying order. A double pendulum, a pendulum hanging from the end of another pendulum, creates movements that seem completely random. But behind this apparent randomness exists a mathematical structure called a strange attractor, a complex geometric form that governs chaotic movement. Have you observed how water forms vortices when going down the drain? The rotation direction is not determined by Earth's rotation, as many believe, but by small asymmetries in the container shape and water's initial movement. It's an example of how minute perturbations can determine macroscopic patterns. The movement of galaxies through space creates the largest scale of geometric patterns we know. Galaxies cluster into giant filaments extending billions of light years, creating a cosmic web that resembles a giant brain's neural structure. It's as if the entire universe were organized according to geometric architecture of unimaginable proportions. And perhaps the most mysterious of all movements is the expansion of spacetime itself. The universe is not just expanding, it's expanding in an accelerated way, each point in space moving away from all other points according to a geometry we're still trying to understand. This makes us reflect on our own relationship with movement and geometry. Are we, with our daily movements, our walks, our dances, participating in this great cosmic choreography? Are we part of the universal movement patterns or external observers trying to decipher their rules? Approach a flower. Any flower. A rose in the garden, a dandelion on the sidewalk, a daisy in the field. Observe it not just as a beautiful decoration of nature, but as an open book written in a mathematical language you're learning to read. Each petal, each pistil, each stamen carries information encoded in a geometry that connects this individual flower with the cosmos's most fundamental patterns. Count your flower's petals. If it's a daisy, you'll most likely find 13, 21, 34, 55, or 89 petals. If it's a lily, you'll find 3 or 6. If it's a wild rose, you'll find 5. These numbers are not coincidence. They're part of specific mathematical sequences that nature uses as templates for creation. Look at a sunflower's center. Those small flowers forming the central disk are not randomly arranged. They follow 2 series of interlacing spirals, one rotating clockwise, the other counterclockwise. And how many spirals are there in each direction? Always consecutive Fibonacci numbers, 21 and 34, or 34 and 55, or 55 and 89. The spiral organization is not just beautiful, it's functionally perfect. It allows the sunflower to pack the maximum number of seeds in the smallest possible space, ensuring the next generation most efficiently. It's as if each sunflower were a biological computer that solved a complex spatial optimization problem. Have you examined a daisy closely? See how the petals radiate from the center according to specific angles. This radial arrangement ensures that the flower is visible and accessible to pollinating insects coming from any direction. It's a universal design that works in 360 degrees, a perfect biological landing strip. Think of an orchid. These flowers develop forms so specialized that each species often has only one specific type of insect that can pollinate it. The flower's geometry is sculpted by the insect's geometry in an evolutionary dance extending over millions of years. It's as if flower and insect were 2 halves of a geometric equation that only works when united. Roses follow spiral geometry in their petals. Each petal is positioned according to a specific angle in relation to the previous one, creating an arrangement that maximizes light exposure and creates that iconic shape we associate with beauty and romance. It's mathematics transformed into vegetal poetry. Have you noticed how some flowers open and close following specific schedules? These clock flowers respond not just to light, but to internal circadian rhythms that echo Earth's rotation. Carl Linnaeus, the famous botanist, even created a floral clock by planting flowers that opened at different hours of the day. Flower color also follows mathematical patterns. The light frequencies we perceive as colors are related by specific proportions. Yellow flowers reflect different frequencies than blue flowers, and these differences are precisely calibrated to attract specific pollinators sensitive to those particular frequencies. Some flowers, like poppies, have petals that look like crumpled paper. This apparently irregular texture actually follows fractal patterns that maximize the petal's surface while minimizing the material needed to build it. It's an elegant solution to the problem of how to be large and visible using minimum resources. Have you observed how certain flowers follow the sun's movement throughout the day? This phenomenon, called heliotropism, is not just mechanical turning. The plant continuously calculates the sun's position and adjusts the flower's orientation to maximize light capture. It's as if each flower were a small biological astronomical observatory. Flowers that open only at night, like the night-blooming cereus, follow different geometry. Their petals are often white to reflect the little available light, and their shapes are optimized to attract nocturnal pollinators like bats and moths. It's a specific design for the nighttime environment. Flower fragrance also has geometry. Aromatic molecules have specific shapes that determine how they fit into animals' olfactory receptors. A minute change in molecular geometry can transform a pleasant fragrance into an unpleasant one. It's as if smell were molecular sculpture. Some flowers, like chrysanthemums, are actually composed of hundreds of small individual flowers organized according to fractal patterns. What we perceive as a single flower is actually a community of flowers working together, each contributing to a collective design more efficient than any individual flower could be. Have you observed how flowers wilt? Even in the death process, they follow specific geometric patterns. Petals curl and fold according to lines of least resistance determined by cellular structure. It's as if even deterioration followed programmed geometry. Cross-pollination creates a geometry of relationships extending across entire landscapes. Each flower is connected to others through pollinator corridors, creating reproductive networks that can extend for kilometers. It's a biological internet where genetic information travels from flower to flower through insect messengers. The seeds resulting from this pollination also carry geometry. Some are equipped with wings to travel in the wind. Others have hooks to attach to animals. Still others have perfect spherical shapes to roll across the ground. Each shape is optimized for a specific dispersal method. Have you blown a dandelion and watched its seeds float in the air? Each of these seeds has a parachute of fractal structure that maximizes air resistance while minimizing weight. It's aeronautical engineering developed through millions of years of natural selection. Flowers also teach us about temporality. Some bloom only once a year. Others maintain flowers throughout entire seasons. Some flowers last only a day, others remain open for weeks. Each temporal strategy is synchronized with pollinators' life cycles and environmental conditions. Flower geometry has profoundly influenced human art and architecture. Gothic rosettes, floral patterns in fabrics, mandalas based on floral forms. All these human creations echo the geometry we first learned by observing flowers. And perhaps most poetic is that flowers teach us that mathematics can be simultaneously functional and beautiful. Each geometric aspect of a flower serves an evolutionary purpose, but the total result is of a beauty that transcends mere function. It's as if nature were showing us that efficiency and elegance are not opposing concepts, but faces of the same deep truth. When you offer flowers to someone you love, you're offering geometry crystallized in beauty, mathematics transformed into poetry, evolutionary function transmuted into expression of affection. You're offering small universes of proportion and harmony, each carrying the geometric secrets of life itself. Close your eyes and try to observe your own thoughts. See how an idea arises, connects with a memory, which in turn awakens an emotion, which generates another idea, in a sequence that branches like tree branches or leaf veins. Your consciousness, this most intimate and mysterious phenomenon, may itself be a fractal structure. Think about how you organize your memories. A specific song can trigger childhood memories, which in turn evoke the smell of your grandmother's kitchen, which awakens summer vacation memories, which connect with feelings of nostalgia. Each memory contains other memories in a recursive structure resembling the fractals we find in nature. Have you noticed how your dreams work? In a dream narrative, you can be in a house that is simultaneously your current house, your childhood home, and a completely imaginary place. This capacity for your dream experiences to fold upon themselves, containing multiple simultaneous realities, resembles the self-similar property of fractals. Your physical brain is literally a fractal structure. Neurons branch like microscopic trees, each dendrite dividing into smaller ramifications, which divide again, creating a giant contact surface compacted in your skull's limited space. It's as if nature had used fractal geometry to maximize information processing capacity. But consciousness's fractal geometry goes beyond the brain's physical structure. The way you process information also seems to follow fractile patterns. When you understand a complex concept, It's often because you manage to see how smaller parts relate to the whole, and how the whole is reflected in the parts, an essentially fractal perception. Have you experienced those moments of sudden insight, when a solution to a problem spontaneously appears in your mind? These eureka moments often happen when your brain finds fractal patterns, connections, between different levels of information that suddenly align in coherent understanding. Human language also exhibits fractal properties. Words combine into sentences, sentences into paragraphs, paragraphs into texts. But more than that, each word carries multiple layers of meaning that unfold according to context. A simple word like home can evoke architecture, family, security, childhood, depending on how it's used and who hears it. When you tell a story, you're creating a fractal temporal structure. The main narrative contains sub-stories, which contain details, which contain emotional nuances. Each level of the story contains information about the whole, and the whole is built from its interconnected parts. Have you noticed how your emotions organize? A primary emotion like sadness can contain within itself multiple layers: nostalgia, melancholy, longing, resignation. Each emotional layer contains other layers in a structure resembling Russian dolls nested within each other. Empathy, your capacity to understand other people's feelings, can be seen as a fractal process. You internally simulate another person's mental states, creating a fractal copy of alien consciousness within your own mind. It's as if your consciousness were capable of containing other consciousnesses in miniature. When you learn something new, knowledge integrates with what you already knew according to fractal patterns. New information connects with existing information at multiple levels, creating an understanding network that is more than the sum of its parts. It's as if learning were a process of fractal growth of consciousness. Have you meditated and observed how your attention works? When you try to focus on your breathing, your mind invariably wanders. But if you observe carefully, you'll see that even this wandering follows patterns. Thoughts branch into other thoughts, which branch again, creating a tree of mental associations. Creativity also seems to be a fractal process. When you have a creative idea, it usually arises from the unexpected combination of apparently unrelated elements. Your unconscious mind explores fractal connections between different knowledge domains, finding patterns your conscious mind hadn't yet perceived. Have you noticed how different cultures organize thought differently? Some cultures think more linearly, others more circularly or spirally. These different thought geometries may reflect different ways of organizing conscious experience, different fractal architectures of mind. Music that most moves us often has fractal structure, melodies that repeat at different scales, rhythms that echo larger rhythms, harmonies that contain echoes of themselves. It's as if our consciousness recognized in external music the fractal patterns of our own mental processes. When you fall in love, your consciousness reorganizes fractally. The beloved person becomes present at multiple levels of your experience, in specific memories, in general associations, in future expectations. It's as if love created a fractal pattern that permeates your entire consciousness structure. Spirituality and mystical experiences are often described in terms that echo fractal geometry. The sensation of connection with the whole, the perception that each part contains the entire universe, the experience of infinity within the finite, all these descriptions suggest that altered states of consciousness may involve direct perception of reality's fractal structures. Have you had the experience of déjà vu? This strange sensation that something has happened before may be a glimpse of consciousness's recursive structures, a moment when you perceive the fractal patterns of your own experience. And perhaps most profound is that personal identity itself may be a fractal structure. You are not a single, simple person, but a collection of selves that exist in different contexts, different relationships, different moments. Each self contains aspects of the total self, and the total self emerges from the complex interaction between these partial selves. This leads us to a fascinating question. If consciousness is structured fractally, if thought, emotion, memory, and identity follow geometric patterns similar to those we find in nature, does this mean that our inner mind is built according to the same principles that govern the outer universe? Are we, perhaps, fractal mirrors of the cosmos, each individual consciousness reflecting in miniature the patterns of the infinite whole? Breathe deeply and let your mind expand. Imagine you're floating in space, seeing Earth as a small blue sphere suspended in cosmic vastness. Now, allow your perspective to broaden even more, until the entire solar system is just a point of light. Continue expanding your vision until the entire Milky Way is just one of countless galaxies dotting the observable universe. But even this unimaginable immensity may be just a small part of something even greater. And here we encounter one of the most dizzying aspects of nature's secret geometry. It seems to extend infinitely in both directions, toward the infinitely large and the infinitely small. Have you contemplated a mathematical fractal like the Mandelbrot set? When you magnify a small section of this geometric form, you find structures that echo the whole. Continue magnifying and you'll find more details, always more complexity, in an infinite regression that never exhausts itself. It's as if you were exploring a universe of infinite complexity contained in a finite form. Nature seems to operate according to this same principle. Look at a tree structure. The trunk divides into branches, which divide into smaller branches, which divide into twigs, which divide into even smaller branches, in a progression continuing to the most delicate leaves. Each level of division follows the same geometric principles, creating a structure that is infinitely complex but based on simple rules. Your lungs are another example of this infinite geometry. The bronchi branch into bronchioles, which branch into alveoli, in a fractal progression that creates an internal surface of tens of square meters compacted in your chest's limited space. It's as if nature had discovered that infinity can be folded and stored within the finite. Think of a continent's coastline seen from space. It appears as a smooth, simple line. Approach, and you'll see coves and promontories. Continue approaching, and you'll see individual rocks, then smaller stones, then grains of sand. Each level of approach reveals more details, more complexity in a progression that theoretically never ends. Have you observed how clouds form? A cloud seen from afar seems a simple shape. But as you approach, you see it's composed of smaller vapor masses, which in turn are composed of microscopic droplets, which are composed of water molecules. Each level reveals structures within structures in a hierarchy extending from meteorological to molecular scale. Fractal mathematics teaches us that it's possible to have infinite perimeters in finite areas. A fractal curve can serpentine and fold upon itself so complexly that its total length is infinite, even while contained in a limited region of space. It's a geometric paradox that challenges our intuition about space and measurement. But perhaps the most poetic example of infinite geometry is found in consciousness's recursion. When you think about thinking, you're creating a mental mirror that reflects infinitely. You can think about the act of thinking about thinking in a regression that has no natural end. It's as if consciousness were capable of containing infinite versions of itself. Have you tried to visualize truly large numbers? 1 million is still conceivable. You can imagine a packed stadium multiplied by 10. 1 billion is more difficult. 1 trillion challenges imagination. But the numbers describing the universe, quantity of atoms, galactic distances, cosmic age, are so vast, they completely transcend our visualization capacity. In the opposite direction, the infinitely small is equally dizzying. An atom is 1 trillion times smaller than a pinhead. An atomic nucleus is 100,000 times smaller than the atom. Quarks and leptons are smaller still. And quantum physics itself suggests there may be smaller structures in a regression that may have no end. Infinity's geometry also manifests in repetition. Ocean waves succeed each other infinitely, each similar but unique. Earth's seasons repeat in a progression that has continued for billions of years and will continue for billions more. It's as if time were an infinite spiral where familiar patterns return eternally, but always in slightly different contexts. Have you contemplated the concept of eternity? Not just a very long time, but time without end. Geometry helps us visualize this concept through forms like the circle, a line that has no beginning or end, that returns eternally upon itself. Or the spiral, a form that grows infinitely but maintains its essential identity. Irrational numbers like pi also connect us with infinity. Pi is the ratio between any circle's circumference and diameter, but its decimal expansion continues infinitely without repetitive pattern. It's as if the circle, this apparently simple shape, contained within itself infinite mathematical complexity. Light itself connects us with infinity. When you look at a star, you're seeing light that traveled through space for years, decades, centuries, or millennia to reach your eyes. Each photon carries information from places and times unimaginably distant. It's as if you were a cosmic receiver capable of capturing messages from infinity. The universe's expansion presents us with one of infinity's most mysterious geometries. Space itself is expanding, carrying galaxies away from each other. This means there are regions of the universe moving away from us so rapidly that their light will never reach us. There are horizons beyond which infinity remains forever inaccessible. But perhaps infinity's geometry's most profound aspect is that it forces us to confront the limits of our own understanding. Our minds, evolved to deal with human scales, struggle to conceive the truly infinite. It's as if the universe constantly presented us with mysteries that humble and inspire us simultaneously. And this leads us to a final reflection on our place in infinite geometry. If we are finite creatures in a reality that may be infinite, if we carry within us patterns that extend infinitely in all directions, what is our relationship with this vastness? Are we privileged observers capable of contemplating infinity? Or are we ourselves finite expressions of infinite patterns, small vortices of consciousness in the infinite current of cosmic geometry? And so we arrive at the end of this contemplative journey, but perhaps it's more accurate to say we arrive at a new beginning. Because now, when you step out of this moment of reflection and return to the everyday world, you carry with you new eyes trained to see the secret geometry that was always there, waiting to be discovered. Imagine you're walking in a garden at twilight. The same golden light you always found beautiful. But now you know this color results from the atmosphere filtering specific frequencies of sunlight according to precise optical principles. The same gentle breeze that always calmed you. But now you understand it's part of atmospheric circulation patterns connecting this garden with planetary meteorological systems. Stop before a rose. That perfect spiral of petals that always enchanted you now reveals its deeper nature. It's a manifestation of the same golden ratio that governs distant galaxies, the same Fibonacci sequence that organizes seashells, the same sacred geometry that constitutes your own body. You are no longer a passive observer of natural beauty. You have become a decoder of a universal language, a fluent reader in the mathematics of creation. Each form you contemplate, each pattern you observe, each movement you witness becomes a word in a cosmic conversation in which you now consciously participate. Look at your own hands while holding a fallen leaf. The leaf's veins echo the fractal patterns of your blood vessels. Your fingers' proportions reflect the same golden ratio that organizes sunflower seeds. It's as if you and the leaf were written in the same geometric language, different expressions of the same universal grammar. When you breathe, you now know you're participating in a molecular dance connecting you with distant forests, with oxygen producing oceans, with the planetary atmosphere itself. Each breath is an act of geometric communion with the entire biosphere. Listen to the birds singing in the trees. Your brain now recognizes that those melodies follow harmonic mathematical proportions, that those formation flights obey collective coordination algorithms, that those seasonal migrations create geometric patterns on a continental scale. Observe the clouds slowly moving across the sky. You now see they are three-dimensional fractal structures, dynamic systems that transform water vapor into meteorological art according to precise physical laws. Each cloud is a temporary sculpture in the atmosphere, an ephemeral work of art created by physics and contemplated by consciousness. The water from the fountain in the garden's center is no longer just flowing water. It's a liquid demonstration of how gravity, pressure, and surface tension combine to create flow patterns. Each splashing drop creates concentric waves expanding according to precise mathematical geometries. You walk on a stone path. Each stone is an ancient crystal that grew slowly through geological eras, each incorporating information about pressures, temperatures, and chemical processes that happened long before any form of life existed on Earth. It's like walking on a library of planetary history written in mineralogy. As night approaches, the first stars begin to appear. You now know that each point of light represents an incandescent sphere where atomic nuclei fuse according to quantum physics processes, creating light that travels through space for years or decades to reach your eyes at this specific moment. The moon appears crescent in the darkening sky. You understand that its shape is due to the geometry of solar illumination, that its phases follow precise mathematical cycles influencing oceanic tides, that its very existence stabilizes Earth's rotation and makes complex life possible. You sit on a garden bench and contemplate this extraordinary synchronicity. Billions of years of cosmic, chemical, biological, and cultural evolution align to create this moment when an individual consciousness, you, can contemplate and understand the geometric patterns that constitute and surround it. It's a moment of profound humility and wonder simultaneously. Humility because you recognize being a minuscule expression in an infinitely vast cosmic symphony. Wonder because you also recognize being the part of this symphony that became conscious of itself, capable of contemplating its own geometric nature. You remember all the discoveries from this journey, the spirals connecting shells and galaxies, the fractals organizing everything from trees to lungs, the symmetries balancing everything from crystals to bodies, the golden ratio proportioning everything from flowers to faces, the vibrational patterns connecting sound and form, the sacred proportions making art a discovery of natural mathematics. But perhaps the deepest discovery is that you are not an external observer of this secret geometry. You are part of it. Your cells grow in fractal patterns, your heart beats according to rhythms echoing cosmic proportions. Your thoughts organize in structures reflecting the universe's very architecture. You are simultaneously a reader and a word in nature's geometric language, a contemplator and an expression of the patterns you contemplate, a discoverer and a discovery of universal mathematics. As you rise from the bench and prepare to leave the garden, you carry with you not just knowledge but a new way of seeing. The world hasn't changed. You have developed eyes to see what was always there. Nature's secret geometry wasn't created by this contemplation, it was revealed. Tomorrow, when you wake and look out the window, you'll see fractals in tree branches. When you have breakfast, you'll observe the geometry of sugar crystals dissolving. When you walk to work, you'll notice golden proportions in buildings, movement patterns in traffic, symmetries in the faces of people you pass. You have become a conscious citizen of the geometric universe. Not just an inhabitant of Earth, but a conscious participant in the great symphony of patterns connecting everything with everything, from quarks to galaxies, from DNA to consciousness. And perhaps this is the true magic of nature's secret geometry. It teaches us we are not separated from the cosmos, but intimately intertwined with it. That we are not random accidents in a chaotic universe, but conscious expressions of a deep and beautiful order manifesting at all scales of reality. You now know that when you contemplate a flower, you're contemplating family. When you observe a star, you're observing ancestry. When you study a crystal, you're studying internal architecture. When you listen to harmonious music, you're listening to echoes of your own mathematical constitution. The journey we've just taken together has no real end. It transforms into a new way of living, a new manner of inhabiting the world. Because once you see nature's secret geometry, it becomes visible everywhere, all the time. Thank you for accompanying me on this contemplative exploration. Thank you for lending your consciousness, your curiosity, your capacity for wonder to this celebration of the living mathematics that constitutes and surrounds us. Now, I leave you with a final question to carry with you. If nature uses the same geometric language to build everything from atoms to galaxies, from cells to consciousnesses, what does this reveal about the fundamental nature of reality? And about your own place in this great cosmic conversation that began billions of years ago and will continue for billions more?